Hello again, and I'm redoing this video on the Duplexer because I wasn't happy with some of the results I was getting, and it was a very messy video where I was making a lot of errors. So this is the Duplexer I'm doing the video on, and it's the Diamond MX72A, which is basically a 2-channel duplexer with a common port, and it will take a single signal, in my case from a dual band collinear, 2 meter 70 centimeter collinear, and at the other end of that coax from the collinear you plug it into here, and then it will split it into two ports, one for the VHF side 2 meters and one for the UHF side, which plug into the different sockets on the radio. So okay, let's just again go over the specifications. And it says the low pass filter, which is basically the 2 meter part, goes from 1.6 to 30 megahertz, 140 to 150. I personally think it would go from, it would be more or less flat from 1.6 to 150. But I'm only going to test it from 100 up to 460 megahertz, and the high pass is 400 to 460, which is the 70 centimeter output. So that's what it does, and its power rating 1.6 to 30 megahertz, 400 watts. Excuse me. 2 meters, basically 150 watts, more than enough for me. 70 centimeters, 100 watts, and I've only got available 75 watts on my radio, so that's good enough. And this is the where I got into problems before. I was measuring some strange results that are higher than these figures. In other words, on the 2 meters it should have 0.15 dBs of loss, which is next to nothing. 70 centimeters should be less than 0.25 dB, and in the previous video, which I've scrapped, I was getting a lot higher than that. So that's why I'm redoing this video. And one of my errors was when I connected the tracking generator up with basically a shorting link, I didn't have these 6 dB pads in. I always put 6 dB pads on the output from the tracking generator, and also another one on the input to the spectrum analyzer. It does reduce your dynamic range by 12 dB, but I've found that there is some slight impedance problems on the output and also the input, so you need a bit of padding to sort of give it a bit of a definite 50 ohm or whatever. So if we look over at the screen with that shorting link in, and what I'm doing is I'm scanning on the analyzer between 100 megahertz at this end and 460 megahertz at that end. And the moment with the link in, as you can see, I've normalized it and it's basically 0. That's your reference there, 0 dB. So and I could move that all the way up, the marker. I could move my marker to say 450 meg, and it's still 0. So it gives you your baseline reference. So now the thing to do is to connect up the this duplexer, and I use the common port as the input from the tracking generator, you know, as you would with a collinear aerial, and then we'll look at the output ports. So I'll just connect that up. Okay, so what I've got is I've got the signal going in at the common port, and through numerous adapters, because it's 259, plug and I want to go into N-type, and then I want to go into a BNC, but they're really high quality adapters, so they won't get any losses through that. So now we can look at the performance of the low frequency VHF port, and there you go, that's what you get. You get, if I put my marker back on, so at 145 megahertz I'm getting 0.14 dB loss, but the fatal error again is this is not really looking very nice. It's got lots of squiggly things going up and down, and that's because the UHF port here, there's no termination on it. So if I put a 50 ohm terminator on that, this is what you have to trap for young players. Always terminate your unused whatevers. And now we get a much more smoother response. And it's around 0.13 dB loss, which is next to nothing. And what do the specifications say? They say less than 0.15, so I think that's good. But we're also concerned about, well, first of all we could look at the 3 dB point. 3 dB point, 241 megahertz. Sounds good to me. But what is its response at UHF, this port? I put in 430 megahertz. Now it's down at 60 dB, which is a good isolation at that frequency. That's 1,000,000 to 1 power ratio. So I would say that's pretty good. So now we need to change over, and what I'll do is I'll put the trace, I'll store this trace, I just press view, and that freezes that trace, and I bring another trace up, clear right, that's the purple trace, which is effectively doing the same thing at the moment. And I also need to change my marker over to the new trace. Marker, so trace B. So that should be following the purple trace now. So let me just reconnect and remove the low frequency port connection and connect up the UHF one. So now I've got the basically the UHF output from the duplexer connected to the input of the spectrum analyzer. Yet again I've left this one with no termination on it. This is the low frequency port, and we'll look at what we get on the analyzer. And again we've got all this squiggly bits which shouldn't really be there. But if I put a termination on, which of course you should, now it cleans it up perfectly. Exactly what you want. Now, as this is the 70 centimeter band I'm testing now, I need to look at what we're getting in losses, and we're on 430 and we're getting 0.27, and well, it says 0.25, but I think that's reasonable. In fact, if I tighten these plugs up, it does drop to 0.24. That's another trap for the young players. Always tighten your nuts up, plugs up, whatever. So when you're dealing with RF, you're measuring very small differences in dB. Makes all the difference. So at 430 it's 0.24. Now I go to the top of the UHF band on 440 in this country, in the UK. It's still pretty good, 0.2 dB, and it says in the specs maximum of 0.25, so I think that's working very, very well. And now what we can do now is we can go and look at the response of the UHF side down at 2 meters. So if I dial in 145 meg, it's down at 60, nearly 64 dBs down. In other words, the signal at 2 meters would be 64 dBs down. I mean, I can receive on my radio on one band while I'm listening, while I'm transmitting on another band. So if I was transmitting on 2 meters, the signal going into the duplexer would be 64 dBs down on the UHF input of the radio, and that sounds like a lot, but if I was running 100 watts, say, on 2 meters, there'd still be a fair bit of signal coming into the UHF input of the radio. But that's the best you're going to get, I think, with something like this, and it's more than good enough, I think. What else could I do with it? I could just send a signal into those 2 ports and isolate the input port. Before I do that, let's just have a look at the 3 dB point on that UHF duplexer output, which is basically a high pass filter. This is a low pass filter, obviously, for the low band. This is a high pass, and the 3 dB point 295 megahertz, which is absolutely fine. And where do they cross over then? Not that that means anything to at all. Minus 254 minus 11 dB. Okay. But you're not going to be transmitting on 254, are you? At the risk of complicating things even more, I could do one more test on it. So what I'm doing now is I'm feeding a signal. I'm not using the common port, that's terminated at 50 ohm. I'm feeding a signal into the UHF part, and it's coming out and going into the analyzer on the 2 meter port. So that's another way of checking isolation, if you see what I mean. So there we are, terminated on the common port, and loads of hideous adapters. And now we're back on the yellow trace again, and that's the response between the 2 ports. And this gives you basically the isolation between them. So I go to 145, about the way I was getting before, 63, 64 dB. And the worst point, if I do the peak, is at 240, where the isolation is only 23 dB. That's fine. And I do 430 again, and we're down at 60 dB, basically. 60 dB isolation at UHF from the 2 meter side. So, all very interesting, and it's nice to have equipment like this to be able to test things. So the only other thing to do is have a quick look inside at gain, because I took it apart yesterday, and we can see the various filters they've got in there. Okay, I took it apart, and this is what it looks like. It looks very nicely built, and as you can see, you've got your 2 inputs. This is the UHF side, which comes in and which will be a high pass filter, and that's got two capacitors, I believe, goes from there to the first coil, and then you've got a coil down to earth and another capacitor over to the next stage, another coil down to earth, typical of a high pass filter, then a couple of capacitors in parallel, obviously, which go to the common port. So that's your high pass filter section. And in the 2 meter side, or the low band side, which is your low pass, you've got more or less the opposite way around. You've got the signal coming in with a capacitor down to earth, and then a coil in series which goes to the next section with a capacitor down to earth, which is typical of a low pass, and then a coil from there to the next stage with a capacitor down to earth again, and another coil to the common port, and that is basically it. And this bit here, which initially puzzled me, what is that bigger block of aluminium doing? Well, thinking about it for a while, it's obviously to give you extra isolation between the two input ports, because you got to be so critical at these frequencies. If that wasn't there, you get some leakage, capacitive coupling from this side to this side, and once you get this in the way, it can't escape through. Of course, you can still get a bit through here, but maybe it's not just so critical at that point. It depends on whether it's a high impedance point or a low impedance point, I suppose. If it's a low impedance point, you'll get inductive coupling, and high impedance you get capacitive coupling and all that rubbish. So that's what it looks like inside, and it's very nicely built, and I think they've done very well with this to achieve such low losses in quite a small box. And of course, when you put the lid on, that will improve its performance even more than it would with the top off. It's always best to have the lid on if you can when you're dealing with RF circuits like that. So there we go. That's the Diamond MX72A duplexer. I always found it to be extremely good. Well built and works well. So thanks for watching, and I'm glad I redid the video. Bye for now.